So in our last video, we were finding a general solution. And so I'll say that this process of finding all solutions is called anti-differentiation. Or another phrase that's often used is indefinite integral or integration. Integration. So I want to talk briefly about the notation that's used here. So you would have y equals the integral f of x plus c. So here, this symbol right here, this is called the integrand. This dx here, this tells us our variable of integration. I'm integrating with respect to x. This capital F, remember that we called this the antiderivative. And then this plus c, the c here is called a constant of integration. So that's all of the terminology here. And I want to make another note now. Integration and differentiation are inverse operations. So let me formally tell you what I mean by this. If I take an integral of a derivative of capital F prime of x, it's going to spit out f of x. But because it's an integral, we have to have our constant of integration there, so plus c. So essentially, the integral kind of undoes the derivative there. And then if I flip it, if I take a derivative of an integral, I just get back f of x now. So they truly are inverses of each other. They kind of undo each other. So now I want to talk about some basic integration rules. So there are going to be several of these, and we're just going to work our way through the list. The integral of 0 is just c. Constant functions have derivative 0. If I integrate a constant like k, I get back kx plus c. If you have a scalar times a function, you can pull the scalar out of the integrand. If I'm taking the integral of a sum or a difference of two functions, I can break it up into the integral of the first function plus or minus the integral of the second function. Just like with derivatives, you can take the derivative term by term. The same thing you can do here, term by term. Number 5, the integral of x to the n is x to the n plus 1 over n plus 1 plus c. is supposing, here I'll say that n can't be -1. So I usually call this rule the reverse power rule, because you're kind of doing the opposite of what you did in the power rule. In the power rule, you subtracted 1 from the power. Now you're adding 1. Before you multiplied by the power, now you're dividing by the power. Rule number 6, the integral of cosine is sine, because the derivative of sine is cosine. The integral of sine is a minus cosine. The integral, these next ones are all trig functions. The integral of secant squared, what function has derivative secant squared? It's tangent. The integral of secant times tangent, which function has derivative secant times tangent? It's secant. The integral of cosecant squared, well, the derivative of cotangent is a negative cosecant squared, so you'll get a negative cotangent. The same thing for the integral of cosecant cotangent. It's negative cosecant plus c. We're almost through our list. Now number 12, the integral of e to the x is e to the x plus c. Remember, the derivative of e to the x is itself. Number 13, the integral of a to the x. It's 1 over ln a to the x plus c. So if you remember with the derivative, you multiplied by ln of a. But here we're doing the integral. The opposite of multiplication is division. And then our very last rule, it's kind of related to something we talked about before, 1 over x. Remember our reverse power rule, n couldn't be 1 or -1. And so here, which function has derivative 1 over x? It's ln of x plus c. So these are our basic integration rules, and now we're going to take and compute some integrals.